the formula is giving us an squared plus bn plus c. I'm going to do a little bit of simulation here with expression and do another one with real numbers, match the two and create equation and form a general relationship that will help us work out quadratic sequence. Given this formula, I can use 1 to create the first expressional term, I can use 2 to create the second expressional term, and I can use 3. So let's see what will happen when I do that. So I'm going to generate the first 3 terms, but it's going to be in an expression form. Substituting 1 to the formula, our first expression will be a plus b plus c, so that's be my first term as an expression. Substituting 2 for a plus 2b plus c, that's my second expressional term. And substituting 3, I'm going to get 9a plus 3b plus c. So I've now formed a quadratic expressions. I'm still going to use the same principle by finding the differences between the terms. And to find the differences, it's always the current minus previous, current minus previous. So 4a minus a, 2b minus b, and c minus c. And if you did that correctly, our first difference will be 3a plus b. Next one, 9a minus 4a, 3b minus 2b, and c minus c. Also, if you done that correctly, you're going to get 5a plus b. Now, I need to go for my second difference. 5a minus 3a and b minus b. That will give me 2a. And my expressional sequences will settle on a constant 2a. If I carry on the pattern, I'm going to still have 2a throughout. Okay, now I'm going to do a real number sequence and compare the relationship. First set of differences, second set of differences. So that's what I've got so far. Now you can see there's a pattern here. Position of 2a is plus 4. Position of 3a plus b is plus 3. Position of a plus b plus c is plus 4. Now there's a relationship between the two. So 2a is always equal to the second difference. So always 2a is equal to the number that you end up with as your constant difference. Always. 3a plus b is always the first term of the first difference. The first term of your first difference. And a plus b plus c is always equal to the first term of the original sequence. So all you need to do is to remember this expression in that format. Let's work this out. 2a, we said, must be equal to the constant difference. So 2a must be equal to 4. So when we work it out, 2a equals 4, a will be equals to 2. Next is 3a plus b must be equal to 3. But we know a already computed as 2, and 3a is 3 times 2. So we're going to have 6 plus b equals 3. And to find b, our b is negative 3. And lastly, a plus b plus c must be equal to the first term 4. We know a already is 2, a is 2, b is negative 3. So we substitute that. 2 minus 3 plus c equals 4. Negative 1 plus c equals 4. So we know that c is equal to 5. So now that we know our a is 2, our b is negative 3, and c is 5, all we need to do is replace a, b, and c with the values that we computed. And that's our formula. So the formula for this sequence, 4, 7, 14, 25, and 36, is giving us 2n squared minus 3n plus 5. And you can double check to see. Let's work out 7. 7 is the second position, so n is equal to 2. 2 squared is 4. 4 times 2 is 8. 3 times 2 is 6. 8 minus 6 is 2. 2 plus 5, 7. It works.